Here's my first example for section 3.3. And I haven't written out all the parts yet, but you're going to find when you do the homework assignment and even the quiz, they're going to ask you to do more than one thing. Okay, it'll be like part A, part B, part C maybe. Okay, so I'm going to give you a quadratic function here. I'm going to ask you a bunch of questions. I usually start with finding the vertex. Okay, almost every problem in your assignment is going to ask you to find the vertex. My preferred method is to use this little formula. It's not really a formula, but this little rule to find the vertex. Okay, so if we do that calculation, most of our work is going to be done for us. So our x value is negative b over 2a. Remember, our b is negative 5. In this case, our a is 1. So that's going to give us 5 over 2, which this is the point where I do prefer decimals, because on the next step, what you're going to do to find the corresponding y value is you're going to plug that 2.5, you're going to plug that 5 halves in for x. That's what this little expression is telling you to do. Find f of negative b over 2a. So what we're going to do is take that and plug it into your original function. Okay, so I'm going to choose to use 2.5 because I'm lazy. I'm going to use a calculator here, but if you want to do the fraction, that's totally acceptable. You're just going to find it takes more time. Okay, so my vertex is 2.5 comma negative 12.25. Remember, we're just being asked to find an ordered pair. When you are asked for the vertex, you just need to find a point on a graph. So there it is. That is the vertex for this parabola. Okay, so the next thing that they may ask you in your assignment is to find the axis of symmetry. I'll circle that vertex. The axis of symmetry calculation is actually already done. It's x equals 2.5. Okay. Next thing I'll mention here is I'll ask you if this opens up or down. Now, that's the easiest question of all. The leading coefficient is a 1. Okay, it's a positive number, all right? And so that tells us that this parabola opens up. You need to be prepared for the fact that sometimes the questions are worded differently. It doesn't always say, does it open up or down? It might say, does the function have a maximum or minimum value? So if this parabola opens up, it has a min. Okay, has a minimum value. So next thing I'll ask you to do is just do a general sketch. Now your assignment isn't going to ask for this. Well, actually it will, but your quiz on my math lab won't. We know where the vertex is. It's down here somewhere. Okay, and we know that this thing opens up, and it's got a y-intercept of negative 6. Okay. So again, I'm not graphing this really detailed. I just want to draw a sketch just to demonstrate here. Because the next thing I'm going to ask you is for the range, okay? And this should be review at this point, but if it's not, here it is. The range of this function is all of your acceptable y values. Okay, now this vertex right here, remember, was 2.5 comma negative 12.25. So the y values that are being shown on this graph are bottoming out at negative 12.25. So our range is going to be from negative 12.25 up to infinity. Okay. And we could close that with a bracket. Another way to say that is the range is greater than or equal to negative 12.25. But the range, remember, is just all of your y values that are being covered with your function, that are being expressed with that function. The last thing that I'll review here is the increasing, decreasing. Okay. So another thing they may ask you in your assignment is to describe where this function is increasing and where this function is decreasing. Okay. Now I choose to use set notation for this. There's other ways to do it, but from our little sketch up here, we have a decreasing function coming from left to right. Our function is decreasing from negative infinity over to 2.5. And then at 2.5 it starts to go up. 2.5 up to infinity. For the rest of the graph, it starts to go up. So that's the regions. Those are the regions where it's increasing and decreasing. So that's a very detailed example. I'll do one or two more like that, but I'm doing a lot more here than you may be asked to do in each problem in your assignment.